Let's get the show on the road today. Let's see if we can get some. There we go. So we have a test a week from today. That's right. So the midterm will be up through material covered on Thursday. That's not what I wanted. So it will cover up through basically HTML, which is what we'll get to on Thursday. There's a sample exam up on, if you follow sample exams, then you can see what the midterms have looked like in the past. And you can be pretty sure that the format will be generally the same as it was in the past. So there'll probably be some fill in the blank like you see here, and then some multiple choice, especially on the information management stuff. That's how I'll be testing the information management, is with multiple choice, multiple answer. Then we did generics, we did inheritance, you did Java. There's likely to be a little programming involved. Okay, so you need to make sure that you're comfortable. I would say that I would, with generics, if I make you program something, it will be in Java, but I would ask you multiple choice questions on the C++ and C stuff. But if it's going to be a programming question on generics, it will be in Java. Same thing with inheritance. So basically anything that's programming related, it will be in Java, okay? But you need to be able to answer multiple choice or fill in the blank questions for C and C++, or read code in C and C++. Okay, so there'll definitely be generics, inheritance, modules, and just a generic Java programming question. And remember, I guaranteed you something on exception handling. And that was a C++ thing that I guaranteed with exit and why you shouldn't use it. So there will be an essay question on that, guaranteed. So make sure you study that and know why you're not supposed to use exit, why you use exception handling instead in C++. So, and then as I said, the way I'll test all the information management, including the HTML, is through multiple choice. So quizzes that you've been taking throughout the semester are also a good study tool, in addition to looking at the sample exam. And I believe, just a second, I didn't check this, but I think I have a study guide for the, yep, so make sure I have that. So I'll post it. I have a midterm review thing. I will post that, probably with the sample exam link. I need to update it because in the past we didn't have information management. I'll try to get that out by tomorrow. So you'll have the entire class period for it. Any questions? Yes.
So, how would, I guess for the midterm review, how well would you say that?
Well, it's kind of just a going over what I thought were the highlights of what we covered. So it's more, I think, yeah, highlights of what we covered and the concepts I think you need to know for the exam. It's not, like you can see here, garbage collector, reference counting tray. I didn't say what it was, so you're going to have to go and make sure you know what those things are. So it's kind of more, I guess, hitting what I think are the important, the most important salient things.
And if you know, but if for example, you can go through this review and say, okay, garbage collection, parking suite, I understand that.
Mm-hmm.
And you can do that for everything on the review.
I think you're in good shape. Yeah, you should be in fine shape. Mm-hmm. Yep. So, other questions? Okay. At 1:45, if I forget, someone let me know so I can make the quiz available, okay? So I don't run you over today. Okay. So, we are finishing up today with the talking about various aspects of information management. So remember, last time we primarily went through content capture and how you digitize content. So we also went over compression. I think, did we go over color maps last time or not? No. So we have to do that. That's important. And today we're going to be going through how we, so storage is kind of the various formats like JPEG for photos or .wav files for audio. Management is how you manage the collection of items that you have. So today we're going to talk about content management, how the different kind of forms of management, and then a bit about content analysis and navigation, and then a bunch of stuff on presentation, although it's more things you should know about the human perceptual system for when you're actually presenting information. Because I'm a human-computer interaction guy, so I've picked up a lot of things over the years that I think are helpful when you're designing visual displays of information. Okay, so we did talk about compression. We did not talk about color models. I did update. I did some research. So turns out that, yep, movies definitely at 24 frames per second. It appears on your smartphones you can, I can't spell weather. You can, on your smartphones, apparently do 30 or 60 frames per second. TV shows are recorded at 30 frames per second, but TVs are refreshed at 60 frames per second. And more modern TVs are up to 120 or even 240 frames per second. Were you looking that way? Yeah, I read, I'm not a film expert. They said there's various issues that are involved with converting movies to 60 frames. They said it's an issue. Like they would duplicate odd frames and do something with even frames. And because even if you duplicate everything, you're still only at 48. So you still have to do something. And I didn't read it all. It wasn't someone's. By interpolating? Okay, so there's stuff you can do, but they said it is a pain in the neck to adapt movies to TV. I'm guessing that with TV shows, all they have to do is duplicate the frame, but maybe they interpolate again, who knows. And the reason for this is supposed to be sports, but I'm not sure if ESPN even is shooting at those frame rates. So, but I know I've seen TVs claiming that you should buy them at 120 megahertz because you'll get better sports action at that level. The question is anyone even shooting at that? Okay, so I just wanted to point that out because I looked it up. Okay, then the other thing, we went over compression in the storage formats. I didn't get to it because I told you to look at everything, but I didn't talk about color models. There is an important thing with color models that I did want to just point out. So when you store images, there's 4 different color models in common use. The very simplest ones are black and white. They just use bitmaps. 1 is black, 0 is white, or vice versa, depending on how they do it. Grayscale is a form of black and white, but it varies the intensity or the saturation. We'll get to that today, but the amount of white in the black makes gray. So gray, there's continuums depending on how much white light is in the black. So you can get grayscale, several bits per image. Normally it's from 8 bits, 0 to 256. In the early 1990s, the NeXT system, anyone ever hear of NeXT? It's where Steve Jobs went after he was fired from Apple the first time, found it NeXT, and then you can thank the current Unix environment in the Macs for NeXT because he thought that Unix, apparently they used them in the NeXT computers and thought they were good. Anyway, it'd be unusual to see grayscale nowadays, but maybe old black and white photos If you scanned them, you'd probably do it with grayscale. Old black and white movies would probably be in grayscale. Full color. So that would probably be the most common color model used today. And they use 8 bits per color. So red, green, and blue are the 3 so-called primary colors. Each one gets 8 bits. And the reason for that is the human perceptual system can distinguish about 256 shades of color. And therefore, you don't need more than 8 bits. It's also ridiculous as they're slowly getting more and more color resolution in the TVs because there's actually a limit to your human perceptual system. So at some point, they're taking your money. Yes?
Do you mean that each color value gets a byte?
Yes, 8 bits. So each color gets 1 byte. There's 3 bytes per color. So 1 byte for red, 1 byte green, 1 byte yellow. That gives them 8 bits, 256. Then they meld them together to get the full color. And then it used to be that storage was more limited, so they didn't want to go with a full 3 bytes per pixel. So instead they'd use a color map. In the color map, the start of the file contains a color table, typically with 256 colors. Each pixel is an 8-bit quantity that is a map into that color map. The color map itself uses 3 bytes for each color, but you only get 256 colors. So it's much more limited. GIFs are an example of a format that uses color maps. That's why GIFs are kind of limited in what they can do. You'd probably never use a GIF to represent a photo because there's just not, you can only get 256 colors in a GIF. Another thing is, if you want any kind of color gradation, then GIFs are bad because 256 colors, you can't really get a very good color gradation. If you're going from, say, a light green up to a darker green by doing some kind of gradation, you're quickly going to run out of colors in your color map. But there are earlier, typically the more recent image formats use full color, but some of the other ones that are still in common use, like GIFs, use a color map. So, any questions about that? But also, if you ever wonder why GIFs can look a little hanky, that's why. They're limited in the number of colors they're able to actually show. Okay? But conversely, and I'm just pointing out a couple things because I didn't. If you ever wonder why a JPEG image looks a little bitmappy when it's blown up, or when it's showing lines, straight lines that are graphics or circles, it's because it's lossy. And so it's not actually able to precisely represent that thing, and it's relying on the fact that you're not blowing it up to see that lossiness. So you wouldn't use JPEGs to store graphics like circles or rectangles or squares because it's a little lossy. You use it for photographs where you don't typically have a lot of straight edges in it. Okay, JPEGs aren't as good for that. Okay, so, and then, I don't know, for those of you who've used Macs, you may be pissed off like I do that it seems like Macs use TIFF and no one else does, but it's not quite as bad as it seems. TIFF is used more frequently than you might think because of this quality. Non-compressed lossless. Okay, so sometimes when you're storing documents, especially source documents that researchers might want to go back to and analyze in great detail, TIFF is a good format because it's lossless. Okay, I'm mentioning that because in your homework assignment, that might come into play. Okay, generally when you are trying to preserve documents, you don't want to lose something because researchers may want to go back at some point, like to a 1,500-year-old document, and they might not be too appreciative if you've lost a certain few bits. And so TIFFs are actually good for preserving that because they're not compressed and they are lossless. Obviously, they're huge. Okay. So that was storage. Now we move on to how you manage content. Okay, so you have a big collection of documents. How do you manage them? The number one way is still via databases, and the number one way of that is relational databases. I still get irritated when I get a couple things saying Dr. Van der Zanden spends too much time on relational databases. NoSQL is where it is. And then I talk to my friends yet again in the industry, and they say, yeah, NoSQL is faddish and hot. Relational databases are still way dominant. Okay. Over break, I was having lunch with my cousin, whose company does some kind of database where they keep licensing information. It sounded perfect for NoSQL, so I asked him, so you're doing it in NoSQL? And he just smiled and said, nope, we're using a relational database. And I asked him why. He said, because of the query language. He said that with relational databases, the end users can query the database, and that's not true in NoSQL. And he said it's absolutely critical that his end users can query the database. We'll get into all of that, but at any rate, databases, they could be NoSQL, they could be relational. Relational databases are still the 64-pound gorilla, but it's certainly the case they're not the only show in town. And our last lecture after the exam will go over relational versus NoSQL. For the time being, just know it's the most common way to store collections of data. So they typically, in the way I talk about them, require the data be structured, not semi-structured. We'll get to semi-structured in a moment. But databases, relational databases are the primary one. They typically provide three types of features. They provide a data definition language that allows you to define the structure of the data. So that's like your declaration system when you declare variables in a program. That's the data definition language. You're declaring, like when you declare an object in a class, in a relational database, that's a bit like specifying something called a table. Okay? And then they have fields within those tables, just like objects have instance variables. Those fields have types. So the data definition language lets you specify the tables, the fields within each table, the types of each field, and then constraints. For example, you might not want anyone to make more than 40,000, or you may not want any property manager managing more than 100 properties. So they allow you to enforce constraints on the data for consistency. Then there's a data manipulation language that allows you to query the database. It normally supports these four operations: insert, update, delete, retrieve. You often hear them referred to by the acronym CRUD. Create is insert, read is retrieve, update is updating information, D is delete. So when you hear CRUD operations on a database or on any document collection, it refers to create, read, update, delete. Okay? And then the third thing it provides is access control. So the obvious one is security. You do that with your file permissions in Unix. You have world readable, your private, and group permissions. So databases provide security. They ensure integrity, so they ensure that the data is consistent. And as part of that, it means something called transaction control. So a transaction is a series of operations that are treated as an atomic unit. So a series of CRUD operations performed as an atomic unit. And it's important that either all of these operations execute successfully or none do. So if any one of them fails, you have to roll everything back. So either they all succeed or if they don't all succeed, you roll everything back to an initial state. You also make sure that you don't get into race conditions between transactions. So that's all part of integrity. Okay, so no race conditions, managing the transactions so that they're atomic and they commit only if everything successfully executes. That's all part of integrity. Concurrency. You want to be able to hit the database concurrently. Obviously, if you're Amazon, you're dealing out product, then you want multiple users able to hit the database at once. But you need to be able to manage that, again, through race conditions. You need to avoid race conditions. So you need to be able to manage multiple users without having integrity issues. Of course, there is crashes of hardware, so you try to recover. Many companies use very expensive storage network devices that rarely fail, but nonetheless, things do happen, so you have to be able to restore the database to a previous consistent state following either a hardware or software failure. They provide a user-accessible catalog. Think of a catalog in a library, a bit like that, although in this case it's more a description of the information, like what are the tables, what are the fields in the table, what are the types. That's the catalog. And finally, they can provide views. So you may not want everyone to have the same view of a database. The view that the CEO has may be different than the view a salesperson has, which may be different than the view that a technician has. So each of them has access to different data in the database. That kind of goes in line with security. Not everyone needs to have access to all the data in the database. So you fashion different views for different people so that they only see what they need to see. Okay, so those are the 6 access things provided by a database. Okay, so questions about databases. We'll get into much more detail with them in a couple weeks. We'll spend a whole day on them. Okay, so that's the first way. The second popular way to store a collection of documents is as so-called document collections. And in this case, they are interrelated. They are typically managed by software, not by a human. And the data tends to be semi-structured. I don't think I had it here, but tends to be semi-structured. And what I mean by that is that each entity, like say a blog post, may have different properties. And so one blog post may have a user ID. It might have, say, contact information. Another one might be anonymous. Okay, so think of Piazza, where some posts have your user ID, other times you choose to post anonymously. So sometimes you have certain properties, other things have different properties. Same thing with photos. You might have a collection in your camera. Some are landscape photos, some are videos, some are your normal portrait photos. So each of them is a little different, has different properties. So those things are not as easily represented in a database. And we call such information semi-structured. And a popular way of storing them is with something called NoSQL databases. NoSQL, so the name of the most common relational database is an SQL database. So NoSQL essentially means not a relational database. And MongoDB is one example. They typically store the documents in something called JSON format. Actually, they probably stored in what's called BSON for binary JSON. JSON itself is character-based. That's a little inefficient, so they try to convert it to binary. So actually, BSON would be the way it's probably stored. And they provide query languages that are primitive. So I should have said primitive. That's a very important thing. It's why my cousin's not using it in his company. Is to basically programmers have to write the query languages. Okay, but they certainly are popular. Social media companies such as Facebook, Twitter, and Instagram use them a great deal, although Facebook also uses MySQL, so it uses a combination from what I'm able to discern. Other examples of collections of documents that are not NoSQL. So NoSQL was one example. Collections of XML documents are another example. They don't often fall under the rubric of NoSQL databases. But RSS documents, which are often generated by news organizations, would be examples of collections of XML documents. So that's another example of document collections. So document collections, semi-structured, managed by software. The query languages tend to be fairly primitive, meaning programmers have to write the queries, which means that if a user, an end user, wants access to the document collection, it's either through a set of predefined queries written by programmers, or they wait for several days or weeks until the programmers get around to satisfying their query. Yes, writing it for them. So relational, yeah, the easiest way to do that is to skip ahead real quickly and show you. So a relational database stores stuff in tables, okay? And the tables have field names or columns. Each column has a name, specific type, and in each cell, there's exactly one value, okay? And if the value can be missing, in which case you would give it a null value. So for example, if someone did not want to provide their gender, you could represent it as null. But there has to be a value in the cell. If you don't want to provide a value, you say null, okay? So, but the data is well structured because generally you expect, for each column, you expect almost every row to have a value. Okay, you don't expect to have would be sparse data. For example, you would expect that almost everyone would provide their gender or their birth date. You don't want a lot of nulls. Okay? If you end up with a lot of nulls, that is what is called semi-structured data, because now it's sparse, meaning that people aren't often providing that attribute value with that row. Okay, so when you hear the word structured data, you can think dense. When you hear semi-structured, what you should think of is if it's laid out in a table like this, it would be sparse, meaning there'd be a lot of so-called null values indicating an absence of a value for that cell. Okay, so think of semi-structured as a sparse table. Okay, so that's the essence of a database. It stores all of its information in tables. Okay, and you can join the tables, but that's getting a little beyond where I want to get, so I won't bother with that. And then in a NoSQL database, do I have an example? It's much more loosely structured. So what it tends to do is in a NoSQL database, you tend to have a bunch of so-called documents. Each document starts with a key, and then it has a so-called record. And the record can have any set of attributes, and notice they're named. So in a relational database, you don't have to name each attribute because it's just in a column. Okay, so back here, this is just in the catalog. This would be in the catalog. The actual table would just look like this. There would be no explicit naming of the attributes. But in a NoSQL database, every piece of data is essentially prefixed. If I can find it again. There we go. You have to prefix every field with its name because it's semi-structured. It's the difference. Think of when you were told how to store graphs, right? One way to do a graph is an adjacency matrix, okay, which works well when it's dense. Another way is each vertex only stores its neighbors, right? That's better for sparse graphs. So that's kind of the analogy with relational and NoSQL. Relational is more like the full-on adjacency matrix, and NoSQL is more like we're just storing the vertices next to us. In this case, we're only storing the properties that actually have values for them. Okay? So NoSQL works much better when the data is really sparse. It's going to really not work well when the data is dense because it's going to take up way more space now than a relational database because it has to store the name of the attribute as well as its value. Okay, so essentially a NoSQL database has a key and then it has a record. The record is itself a bunch of key value pairs. Okay, so it's not nearly as structured, which is what also makes it a lot harder to write really clean query languages over it. Plus, it's just a lot less mature than relational databases. They're much younger. Okay. Don't worry about this for the test, okay, because we'll get into this after the test. Okay, does that help? Okay. Okay, so next after data collections come digital libraries. And a digital library is an online database, but it could be, underneath it could be either a database or a data collection. It typically is involving more than just text. So digital libraries often have a variety of media formats. So one thing about relational databases is they're not quite as good often with non-text. They were designed with text in mind. Okay, digital libraries are storing a lot of a variety of things in addition to text, audio, video, photos, etc. They're typically curated. So that's different than a data collection or a database, which is managed by software. Digital libraries are curated by a human. So the information is organized by humans. It is, what is in there is typically actively selected. They are, it's just much more human intervention. So our professional organizations, both the ACM and the IEEE, have digital libraries with all of their journals that are digitized there. Okay, typically those digital libraries will have an electronic catalog that you can use for searching. Okay, that just may take the form of a search box, but it may allow you to search by, it may provide a search page where you search by author or by topic or by company or by journal. Okay, so it's typically better organized than your normal database or data collection site. Okay, definitely outward facing. Databases and document collections are more inward facing. They're internal. Digital libraries are more outward facing. Okay. Okay, they directly present themselves to the user. A database, Amazon's using a database, but you don't necessarily see yourself directly interacting with the database. You interact with the database through an Amazon interface. Okay? A digital collection is kind of right there that you're interacting with it. Okay, so as I said, distinction between a document collection and a digital library. The digital library is more actively curated. It tends to be available to the general public, while a document collection is being managed by software and is more likely being managed by an organization for proprietary reasons. Okay? They're not as anxious to share that information with you. Facebook is not anxious to share a lot of what it knows with you, okay? Which can be scary. Okay, as I said, this distinction is a bit of a blurry one. For example, social media companies have been forced to start adopting curation practices because of the outrage over different posts. So, I mean, it is blurring, but the distinction is still there. Next, you have repositories. And repositories tend to be more about raw information. So again, the distinction between a digital library and a repository may seem a little blurry, but think of software repositories as less polished. They tend to be raw. They're what we do here at UT because we don't have the time we're not a commercial company. When we publish our research or our software, we're not really there to polish it all the times. We tend to publish it as repositories. Okay, so they typically are open source. They're typically a collection published by a single organization. A digital library often is pulling together, not always, but often is pulling together, maybe pulling together information from different organizations. Think of your public library, which is taking books from many different publishers. Okay, so repositories tend to be more narrow than digital libraries. Their source of information is typically a single organization. A digital library may be like that. The ACM8 digital library only takes information from ACM journals. But there are the Knoxville Public Library is taking information from multiple organizations. Okay. So repositories, much narrower source of information, not as actively curated, a much more raw form of information. Okay, so another way to think of it is digital libraries try to extract metadata from the collection. They're cataloging it. Okay, so repositories tend to be not cataloged. That's one big distinction. They tend to be not cataloged. They're more raw. Okay. Then there is simpler ways, hypertext. Most of us maintain our own web pages. That's a form of information management. We manage our information through our individual web pages, just through hypertext. Okay, HTML obviously is the exemplar of hypertext. Hypertext, though, existed before HTML. It's a markup language that uses links for navigation. So hypertext, simply a markup language using links for navigation. Obviously, HTML is the biggest one. And I saved the most widely used information management technique for last. Spreadsheets are the most widely used information management technique in the world. They also happen to be the most widely used programming language in the world. It's actually not Java, it's not Python, and it's not C++. Whatever they call the language for Microsoft Excel is actually the most widely used computer programming language in the world. Actually, by far, because so many end users use spreadsheets. Okay, so for all the other stuff, it's just we kind of view spreadsheets as beneath us because that's not what we use. Spreadsheets are used by end users. But I want you to be aware of the fact spreadsheets, in fact, are a way of storing information and are the #1 way in the world to store information. It's not databases, It's not Facebook, it is spreadsheets. Okay. Then, physical implementation. So we're storing things, and I'm going to go through this fairly quickly. There are two types, actually there's four types of storage devices these days. You have disks. You have solid state. Be thankful if you have solid state memory. Okay, most cloud memory would be probably solid state these days. You have USB devices, which are good for transferring data between devices. You have tapes, which are very good for archival, but are very slow for any kind of retrieval, but they're very cheap, even cheaper than USB devices. Okay, solid state slowly taking over from disk. It will eventually take over from disk, but one thing you should know, solid state memory, anyone have an idea of roughly how much more expensive it is than disk? Anyone read my notes? You're close, it's 4 to 1. So disks are about 1/4 the cost. So that's the difference, about 4 times more expensive than disk right now. Used to be way worse. And this was 2017. So what were you going to say?
What about the speed ratio from just
I'll get to that. So in terms of the bus, the upper end hard drive devices are the lower end for transmission from solid state. So your very best drives are able to, your enterprise level, get about 200 to 300 megabyte transfer rates per second, whereas your very worst solid state get 200. So the cheap solid state memory in your laptops, and that's what they are, they're bottom of the line solid state, are basically about as fast on their transfer rates as enterprise grade hard disks. And then on the top end, where you're in the cloud with the cloud servers, 10 times faster transfer rates. Okay? And that's when it's found the data. So there's another issue with disks, okay, which is that on a disk, they're spinning platters, okay? Disks are basically organized, if you've ever seen a record, I know many of you haven't. They're essentially, the information is stored on tracks, okay? So they're spinning around, okay? The data might be right here. Well, there's a read-write arm that's going out. The read-write arm might be at this track. So before it can even read something, you have to move the read-write arm out to this other track. Okay, that is called seek time, the time to move the mechanical read-write arm to the appropriate track. Okay, but once it gets there, oops, let's say that it's going in that direction, I just missed it. Okay, it has to come all the way around before I can read it. That's called rotational latency. Okay, it's the time for the appropriate sector of the track to rotate under the read-write arm. The read-write arms don't rotate. The platters rotate. Okay, so before you even get to the point where you start transmitting, you have seek time and rotational latency. Okay, and it's hard to speed that up. There's a limit to it because obviously things start to shake. Okay, so that's a problem. So here you go. 3 to 4 milliseconds just for a high-end enterprise grade. 9 milliseconds for your desktop. 12 to 15 milliseconds for your for your mobile device or laptop. Okay, that's not great because that means no more on your laptop. That means no more than 100 times a second can you move the read-write arm. Okay. And then rotational latencies anywhere from 2 to 7 milliseconds. Okay? And that's even before you start transmitting. So the question earlier was how fast they can transmit. Okay, already the top of the line is no better than bottom of the line solid state, and that's only when they finally get to the point. They've already blown probably 5 at the minimum, 5 milliseconds high end. At the bottom end, they've blown up to 20 milliseconds just getting to the piece of data, to the right place. Okay, solid state, what is their latency? Their latency less than 1.1 milliseconds. No latency for rotation. There is some addressing issues, so that's why you have slightly less than 0.1 milliseconds. You still have to address, you have to get to the right point. I'm not a circuits guy. I can't tell you exactly what's going on, but it's not instantaneous to get there. Okay, there's still a slight delay. Okay, here it is, about 24 cents per gigabyte in 2017, about 6 cents per gigabyte for hard disk. Okay, I don't know for the hard disk. I'm sure that enterprise is more expensive than your laptop, and I forget now, I didn't reference where I got this information, so just in general, it's about 4 times greater right now than for a hard disk drive. It'll come down. Okay, one thing you should know about SSDs, for the cheap ones in your laptops, write times are about 1/10. I'm sorry, 10 times greater than the read time. So writes to solid state memory on the cheaper ones, 10 times longer than reads. On the ones in the cloud, they're the same, but they're much more expensive. Okay, again, I'm not a physics person. Someone told me it takes a lot more energy to write than it does to read because you have to flip the polarity. And not only flip it, there's some resistance or stasis to flipping, so you need to overcome it, and that slows everything down. Okay? I'm not a physicist. I can't tell you anything more beyond that. Just know SSDs on your laptops, their write rates are much slower than the read rates. That's why when you're writing to a solid state device, it may seem slower if you're writing a lot than a read. Now you know the answer, because it really is slower. Okay? So, questions about that? Okay. The way files are stored, I'm not really going to hold you that responsible for this. I go over this when in my databases and scripting languages course. The kind of files you typically use are unordered. They're called heaps. They're not the same as the binary perfect trees that you use. They're just called heaps. I don't know, just a heap of stuff. B+ trees are used in secondary storage, not binary search trees. It has to do with the fact that both solid state memory and disks are slower than RAM, but I'm not going to get into it. Same thing, they had to twiddle with hash tables to make them work in secondary storage. So the hash tables used in secondary storage are different than the ones used in RAM. We're not going to worry about it. Okay. You should know that they do try to typically index collections to make access faster. And you need to know the 3 types. This is what you need to know for index. Primary index, cluster index, secondary index. Those are the interview questions you will get. What is a cluster index? What is the difference between a cluster index and a primary index? Okay, so normally records are uniquely identified by keys. Okay, the keys are often artificial, like your social security number, your student ID, your credit card number. Those are all artificial keys. They don't have any natural meaning. Your first and last name could be used as a key. That's a bit more natural, but it's less likely to be unique. Okay? So, When a file is physically clustered on the primary key, we say it is a primary index. That means the records are physically co-located on the disk, okay, according to the primary key. It's called a primary index. Turns out that's pretty rare because it doesn't really make a lot of sense to cluster records on an artificial key. The whole point for clustering is you want to perform what are called range queries. Range queries try to find all information in a certain range, like all people hired in the year 2018. So when you want everything in a range, you want the records to be clustered next to each other so that when you retrieve them, they're right next to each other rather than going here, there. You don't want your read-write arm gibbering around trying to find all the different records that should be right next to each other. At least if they're right next to each other, you only pay the price of seek and rotational latency once. Yes?
So can this range only depend on one type of data?
Yes. Well, sometimes it could be two. Like you could organize first by last name and then do a secondary sort on first name. But that's how it would be. There's always a primary cluster. You could have a secondary ordering if there's ties within the primary. Okay, so if you, pardon?
They call that type of data a primary cluster?
They typically call it a primary order and secondary ordering. I've never heard of the word primary cluster, just,
That's what I like.
yeah, no. So it turns out that most files are not clustered on their primary key. They're normally clustered on another attribute, such as in this case, it would be the employment day. Okay, another common one is last name, is a common cluster index. For races, I used to be a big runner. They might cluster on race times, okay, because you often want to know how many people finished between 15 and 16 minutes. So just know the difference between a primary and a cluster index is primary indices cluster on the primary index, but they're not common because primary keys tend to be artificial. Hence, you don't really want to do range queries on them. The reason you cluster is because you want to do a range query on something. Then you put secondary indices on all other attributes, not all, you selectively use it, but secondary indices are on non-clustered attributes, and they help you efficiently locate records for what are called point queries, where you just want a single record. Like I want to know all people who were hired on February 1st, 2018. Okay, so instead of a range, it's called a point query. Okay, if you say A equals 10 or 20 or 30, that's still a point query. That's not a range query. Okay, giving specific data points, that's a point query. Okay, so you use secondary indices on the non-clustered attributes. That helps you quickly locate where those attributes are. And one advantage of those is you're able to sometimes solve a query without even going to the actual records. If I ask you the total salary for your company, the cumulative amount of salaries paid out, and that happens to be a secondary index, you could solve the query simply from the secondary index, so it is faster. Okay. Now, when you're also managing data, you need to model it, okay? And I have a course that talks about this, so I'm not really going to worry too much about it. But normally when you store information, you identify your entities, okay? Those are the things that physically exist, like people, books, employees in a company, office buildings. Those are physical entities. Then those entities have attributes that you identify. So if you're creating a database, for example, the tables are your entities. The fields within the tables are the attributes, and then you have relationships among entities that you need to model. So for example, a library branch will hold a collection of books. So those are two different entities, branches and books. The branch stores books, or an office will employ staff members. So there are relationships. You need to find a way to model them. In relational databases, you may have two tables. So you may have branches in one, and you would have branch ID. And then here you have books, and each book might have a branch ID that indicates where that book is being held. Okay, so this branch ID in book is called a foreign key because it acts like a pointer into the branches table. It allows you to extract information about where that book is being held. So you don't hold the information in the books table, you hold it in a separate table. So that foreign key is essentially representing the relationship between books and branches. Yes? No, and it's complicated. That's where you can't easily represent. Remember I said one value per cell. Okay, so a branch can have an indeterminate list of books. In fact, probably thousands of books, right? So you can't really have a column for each book that a branch has. So you tend to put it off in a separate relation. Okay, I don't want to go into more detail than that because I'm trying to just do it at a superficial level. Okay, so in databases, the tables are relations, the foreign keys are relationships. Devin. Thank you. So, you want to go online right now? Take a break. We have the quiz. And let's find the quiz. I believe the title of today's quiz is Sunshine. Yes, as a juxtaposition of is it, maybe it's not got an access code. It is Sunshine? Why is it not showing there? Okay, it is Sunshine. Somewhere it is. Okay, are people getting it? Okay. Is Sunshine all lowercase? Yep. Sunshine also happened to be the name of one of my dad's German Shepherds, and he was really sweet. Yeah. So, always brings back good memories. Yes?
I have a question about the libraries versus
Yep.
collections. When you talk about the difference between software and curating it and humans curating it, is the difference there like the style? And that
Kind of like the
or
style, yes.
That it's like is the difference really that it's a human doing it?
I think it's more that the human is doing it than that the computer is doing it. And the fact that for databases and document collections, there's generally not really the idea of curation going on, or updates are being done automatically. Like when you buy something from Amazon, it automatically updates the inventory. It's not done manually by the person. Whereas when a book comes into the library, someone physically, it's more that difference.
Yeah, I was curious because I know that there's a lot of like machine learning clustering stuff, and I didn't know, does that count as?
I would count that more probably as something that is, it gets.
It was like swiftness versus naturalness and robustness.
Yeah, I guess so. There's kind of I would say that digital libraries have more of the flavor right now, at least, of human intervention. Okay. It's Google, you could say, is kind of like a library, but it's using more harvesting and crawling and machine intelligence. So it's not really a digital library. Okay. Okay. So just again with data models, I wanted to show you that each one of the major ones, so databases have entities, spreadsheets, the entities are typically rows or columns, and the relationships are the cells. So in a spreadsheet, like for Canvas, you have across the columns, you have all the assignments. Each row is a student. So those are the entities, and the relationships are the cells. So the fact that maybe I got a 95 on the midterm would be a relationship between midterm and Brad. Okay. In hypertext, the entities are web pages, the relationships are links. So you often see a link to some other related piece of information. You click on the link, you go to another web page. Okay, so data modeling, when you hear it, essentially data modeling means entities and relationships between entities. Okay, next, I'm super weak on this, hence there's not a lot of material on it. So we spent most of the class talking about content management. The next thing is where you analyze it and you navigate it. And I'll be honest, obviously, this is an incredibly important step. It's just not something I do. Okay, Dr. Marcus does it. He has his data mining or data archaeology class. Another professor offers a data mining class. There's pattern recognition that is offered on the ECE side. There's image analysis. So there's a lot of courses in the department that cover content analysis. It's just not my area. Okay, so I can tell you that, first of all, most information collections provide some way of navigating them. So databases provide query languages. Hypertext gives you links. Digital libraries, document collections, and repositories typically have search or filters that you can apply to them, which in some sense the search and filters are limited query languages. They're just not as powerful. Okay. Then there is the way of actually analyzing the information, and that's just, not what I do. So there's the indexing of the data. That could be cataloging it like digital libraries do. It could be crawling through the information like Google does and harvesting information. Okay, there's interesting algorithms. I think Dr. Plank goes through the Google PageRank algorithm in his class. The PageRank algorithm is the way that Google determines the listing of links that appear when you search for something. So he will go over that there. Data mining and pattern recognition. They're using techniques at the intersection of machine language, statistics, artificial intelligence, and database systems. It's just not my area. So it can take an entire course to go over it. As I say, Dr. Marcus offers a data archaeology course. Typically an adjunct professor from Oak Ridge offers a data mining course. Those are electives that you can take. Okay, on the ECE side, there's, I believe, 471 and 472. One of those courses is pattern recognition. The other is image analysis. Those are some other content analysis courses. Okay, and just so you know, constraint solving is something that is done by spreadsheets, and that is another form of constraint solving. I do not have enough time to get into content presentation today, so what I'm going to do is postpone the quiz. But that's good and bad. You'll have 2 quizzes due Thursday. But on the good side, it'll help you prepare for the exam. You can take it either way. So I'm going to postpone the quiz for today. It will be on Thursday instead. And on Thursday, we'll get into content presentation. In fact, I'll leave the quiz up. If you want to take the quiz and just browse through the notes, it's just over what the notes are. You can take the quiz now, or you can wait until Thursday. I'll just extend the deadline on the quiz till Saturday. I will I'll finish up with content presentation on Thursday, and then we'll go into HTML on Thursday. Okay, and I'll get up probably by tomorrow with sample exams. Probably right here I'll have a link to the review document. So with that, I will say, see, just one other quick thing. Notice that 2 things. The homework's not due tonight as it normally is. It's actually due effectively Thursday night, but there's no late submissions because I want to release the solutions immediately. Okay? So with that, I will see you Thursday. Enjoy the sunshine. I plan to.